5-10, arithmetic and geometric sequences. This is a little bit different than what we've been doing in Chapter 5. We are interested in 3 types of sequences. The first type of sequence is an arithmetic sequence. This top example right here. And you can look at the list of numbers, 8, 5, 2, -1, and so forth. And you should notice a pattern between each one of these numbers in the sequence. We're going to do some math to get from one number to the next number in the list. In an arithmetic sequence, the difference between each term in the sequence is the same. And the difference is addition or subtraction. It has to be the same. So if we look at our list, to get from 8 to 5, -3. To get from 5 to 2, -3. To get from 2 to -1, -3. Your work, you're going to have to decide first what kind of sequence a list is, and then you're going to have to find the next term or the next 3 terms in the sequence. So that is an arithmetic sequence. A geometric sequence, the second example we're going to look at, is the quotient between each term in the sequence is the same. And the quotient is, for the purposes of this assignment, is multiplication or division. Because we can divide by a number or we can multiply by the reciprocal of a number. It's just a shortened way of saying geometric sequences, the difference between them is multiplication or division. So, our list, to go from 40 to 20, we would divide by 2, knowing that it's a geometric sequence that we're going to multiply or divide. To go from 20 to 10 is divided by 2. To go from 10 to 5, divide by 2. From 5 to 5 halves, divide by 2, and so on and so forth. You need to decide if something is an arithmetic sequence or a geometric sequence. You need to have this work underneath to help you decide. Sometimes you'll start with both subtraction and division. Sometimes you'll start with addition and multiplication. But you'll have to check both cases until you're absolutely sure it is one of them or it is not one of them. Next, we have an example. 1, 2, 4, 7, 11. So, we need to check to see which type of sequence this is. Okay, to get from 1 to 2, we would add 1. To get from 2 to 4, we add 2. That right there eliminates the fact that this is an arithmetic sequence. This is no longer an arithmetic sequence. So let's see if it's a geometric sequence. To get from 1 to 2, again, we would multiply by 2. To get from 2 to 4, multiply by 2. Things look really good so far, don't they? You have to check every single term in the sequence because to get from 4 to 7, is it times 2? No, it breaks down. This sequence is neither arithmetic or geometric. However, I want you to notice something about it as I erase the geometric trials. To go from 4 to 7, we're going to add 3. To go from 7 to 11, we're going to add 4. Any ideas if there's a pattern here or not? Does a pattern exist beyond this point? Can you continue this sequence? This is neither an arithmetic nor a geometric sequence. However, it is a sequence and it has a specific pattern that it follows. So we have arithmetic, geometric, and neither sequences. Your homework is on page 251, 252, 10 to 32, the evens.